To the third video. Hi, I'm come back for the third video. We continue to find the relative extremum by using the second derivative test. The second derivative can determine the maximum and minimum values of a function if f prime c equal to 0 and f double prime c greater than 0, then f has local minimum at c. Then, if f prime c equal to 0 and f double prime c less than 0, then f has local maximum at c. And then the third one, if f prime c equal to 0 and f double prime c equal to 0, then c is the inflection point. Okay, we will look at when it has local minimum, local maximum, and inflection point, right? Okay, we look at the example 1 by using the second derivative test. First, find the relative maximum and the inflection points of fx equal to x cubed minus 3x squared, and we will sketch the graph, right? So first, what we need to do is find the first derivative, okay? Differentiate. Differentiate the 3x squared minus 6x. Okay, x will be equal to 0 and x equal to 2. We differentiate this one, x cubed minus 3x squared. So we will get 3x squared minus 6x. This x equals to 2 and x equals to 2 is the critical point, right? Then by using the second derivative test, we need to differentiate once again. Okay? Differentiate 3x squared minus 6x. It will be 6x minus 6. Okay, we know that x equal to 0, so we substitute here into this f double prime x, and then we can get negative 6. Negative 6 is less than 0, so it is maximum, relative maximum. Okay, when x equal to 0, y equal to 0. How to get 0, y equal to 0? You substitute into this, x cubed minus 3x squared. So 0 cubed minus 3x squared, x is 0, so we will get y also 0. Right? So 0, 0 is a relative maximum. And then the second point is the value of x is equal to 2. So yeah, you need to substitute to the second derivative, and then we can get 6. If it is 6 is a greater than 0, that means it is a relative minimum. When x equal to 2, y equal to negative 4. Just now we have 3x cubed minus 3x just now. Sorry, x cubed minus 3x squared. So negative, 2 power of 3 minus 3 times 2 square, 8 minus 3 times 4. So 8 minus 12 equal to negative 4. So y equal to negative 4. So 2 and negative 4 is relative minimum. Okay, and then the next example, by using the second derivative test, find the relative extremum for fx equal to x cubed minus 3x squared minus 24x plus 32. So we differentiate this one, we will get 3x squared minus 6x minus 24, and then we factorize to get the value of x. X is from this one, x equal to negative 2 and x equal to 4 when dy over dx equal to 0, or f prime x equal to 0. So the critical numbers or critical values are negative 2 and 4. To determine the relative extremum for the second derivative, we use the second derivative, okay? So we need to differentiate once again. Okay, we need to find the second derivative. Differentiate 3x squared equal to 6x. Differentiate negative 6x, we will get negative 6. Differentiate the constant, we will get 0. So since x equal to negative 2 and 4, we need to substitute into the second derivative. Okay, when negative x equal to negative 2, the value is negative 18. If it is negative 18, it is less than 0. That means it has a relative maximum. When x equal to negative 4, x equal to 4, right? X equal to 4, f double prime x equal to 18. So when it is a greater than 0, it is minimum. This one, the value of f here, we get from this one. We substitute into this one. X cubed minus 3x squared minus 24x plus 32. Okay? So we will get f negative 2 equal to 60, and then f4 equal to negative 48. So by the second derivative test, negative 2 and 60 is a relative maximum. Okay, this one, negative 2 and 60. And then the second one, 4 and negative 48 is a relative minimum. The concavity and the point of inflection. For point of inflection, f double prime x equal to 0 with a change of sign in the value of f double prime x for the interval before and after the expected point of interval. Means we look at the example 1 here. Find the inflection point and determine the interval where fx is concave upward and concave downward. To find the inflection point, we need to find the second derivative, right? So the first we find the first derivative, then we need to differentiate once again. So 6x minus 12, then we can get the inflection point 2 and 4 here. Okay, we factorize this one. 6x equal to 12. So x equal to 2. When x equals to 2, you substitute to this one. Okay, 2 cubed minus 6 2 power of 2 plus 9 times 2 plus 2. Okay, so we will get equal to 4. So the inflection point is 2 and 4. To determine the concavity, when x equal to 2, the domain, it will be the interval x less than 2 and x greater than 2. Value of x, we can choose any value for x less than 2. So this one we choose 1.5. And then for x greater than 2, we can choose 2.5. And then we substitute into the f double prime. Okay, substitute here. So 6 times 1 over 5 minus 12, it will get negative value. Okay, negative value. And then 6 times 2.5 minus 12, we will get positive value. The conclusion, if it is negative, it will concave downward. If it is positive, it will concave upward. Right? So this one concave downward like this, and then concave upward. Here, given the function negative x cubed plus 3x squared minus 1, we need to determine the points of inflection. And then the B intervals where fx is concave upward and where fx is concave downward. The same like before. First, we need to find the second derivative. So before we need to find the second derivative, we need to find the first derivative, right? So you need to differentiate this one. Negative x cubed plus 3x squared minus 1. So we will get negative 3x squared plus 6x. And then we differentiate once again, negative 6x plus plus 6. To find the inflection point, we need to let the f double prime x equal to 0. So negative 6x plus 6 equal to 0, and then we get x equal to 1. We need to substitute into this x cubed plus 3x squared minus 1 to get the value of y. Okay, just now 1 cube negative 1 cube plus 3x 1 square minus 1. So we will get here negative 1 plus 3 minus 1. Okay. Sorry, the value of x is equal to 1, right? So 1 plus 3 minus 1. So the value of this is equal to 3. Then we look at the interval x less than 1, x greater than 1. Then the value of x, we can choose x less than 1 equal to 0. And x greater than 1, we can choose 2. The sign for f double prime x, okay, you substitute into this one. Negative 6 times 0 plus 6. So it is positive, right? And then the second one, negative 6 times 2 plus 6. So negative 12 plus 6. So we will get negative 6. So the sign is negative. Okay. So if it is positive, it will concave upward. And then the sign is negative, it will concave downward. Right? And then the next example, find the relative maximum and the inflection points of fx equal to x cubed minus 3x squared, and we need to sketch the graph. Same thing as now. Differentiate this one like before. Get x0 and 2 by using the second derivative test. Okay, like before, x0, y0. If it is less than 0, it will be maximum. And then greater than 0, it will be minimum. Okay, the inflection point here, x equal to 1 and y equal to negative 2. So for 0 and 1, the value of x, you can choose in the middle, right? 0.5 in this interval. And the 1.5, we can substitute into this one. 6 times 0.5 minus 6 equal to 0. It will be negative. And then 6 times 1.5 minus 6, it will be positive sign. If it is negative, it will concave downward, and positive, it will concave upward. The curve sketching. So 1 and negative 2 is inflection point. To find the intersection point when x equal to 0 and y equal to 0. Okay, here. X0, y0 here. This is the 1 and negative 2 is the inflection point. When 0, 0, it is relative maximum, and 2 and negative 4, it will be relative minimum. Okay, from here. Okay. Right. Next, for example 2, find the relative extremum in the inflection point for fx 3x power 5 minus 5x cubed f prime x. We need to differentiate this one. So 15x power of 4 minus 15x squared. So we will factorize this one for f prime x equal to 0 to get the critical point. So x is 0, negative 1, and 1. Okay. By using the second derivative test, we need to differentiate once again. Okay, differentiate this one. And then we will get 60x cubed minus 330x. So we substitute the value of x. When x equal to negative 1, we substitute into this second derivative. It will be negative 30. If negative 30, it will be less than 0. It will be relative maximum. So when x equal to negative 1, you substitute into the fx. Okay, this one fx 3x power of 5 minus fx cubed. We will get the value equal to 2. And then when x equal to 1, f double prime 1 equal to 30. If it is a positive value, it is less greater than 0, it will be minimum. So f1 equal to negative 2. So 1 and negative 2 is relative minimum. When x equal to 0, here we have 3 points. F double prime x equal to 0. So x equal to 0 is the inflection point. For the inflection point, f double prime x equal to 0. So we can find the value of x equal to 0 and 1 over 2. To determine the concavity, yeah, from the interval 0 and 1 over 2, it will be negative 1 and 0, 0 and 1 over 2, and then 1 over 2 until 1, the interval, the domain interval. So the value of x we can choose in between this interval, negative 0.5, in between this one, 0.25, and then in between 0.5 and 1, we can choose 0.75. Okay, the sign of f double prime, you can substitute negative 0.5 into f double prime here. Okay, which one? This one, 60x cubed minus 50x. Okay, you substitute, you will get positive, negative, and positive. Positive, it will be upward. Negative, it will be downward. And then positive again, it will be upward. So when x equal to 0, f 0 equal to 0. When x equal to 1 over 2, f 1 over 2 equal to negative 17 over 32. This is the curve sketching. So the inflection points 0, 0, and 1 over 2, and negative 17 and 31. Just now we have 0 and 1 over 2. And then the f0 is 0, and then f1 over 2 is negative 17 over 32. So here, okay, there is an intersection point when x equal to 0, y equal to 0, will be like this. Okay. This one, the point of negative 1 and 2. This one, 1 over 2. 0, 1 over 2. 1 and negative 2. So for x equal to 0 and 0. when x equal to 1/2 here, 1/2, and then y is 1/2, y is negative 17/51. This one 0, 0, 0. Okay, you can do the exercise here by yourself. Okay, see you again later for the fourth video. Bye bye.